Welcome to a presentation showcasing SquidNet's advanced distributed rendering features and workflow. In this video, we'll delve into the fundamental aspects of the main SquidNet user interface, providing insights into its configuration and functionality. Our focus will be on understanding the layout, features, and concepts within this interface. The configuration demonstrated here involves a local render farm environment in Southern California connected to two separate data center networks located in the Netherlands and Germany. While this overview provides a glimpse into the system, future videos will delve deeper into additional features and intricacies. Let's begin exploring. The main SquidNet user interface serves as the central hub for administrators to oversee the entire render farm network. At its core lies the concept of an MDI, multiple document interface, allowing for flexible arrangement of windows and sub-windows within SquidNet. Administrators enjoy the freedom to customize their view layout according to their preferences, thereby enhancing workflow efficiency. While more advanced layout configurations will be explored in later videos, let's initially examine this window layout. Within the interface, several key windows offer essential information and control functionalities. The main job management queue acts as a centralized space for all users connected to the farm, displaying ongoing tasks and their statuses. Furthermore, the active job queue highlights currently processing tasks, providing insights into workload distribution. The GPU nodes window offers a snapshot of GPU usage within the farm, distinguishing between idle and active nodes. Moreover, the farm work queue provides a comprehensive overview of active jobs and their corresponding rendering nodes and tasks. This window facilitates effective monitoring of the rendering process, ensuring smooth operation. On the right-hand side, the job tray presents a preview of the current job being rendered, displaying sample images from each slice. Although these previews are subsampled for screen display, they offer administrators valuable insights into job progress and quality. In SquidNet, jobs are segmented into slices, each potentially containing multiple frames. By examining these preview images, administrators can assess job status and frame quality, facilitating informed decision-making. This intuitive interface design empowers administrators to efficiently manage rendering tasks, optimizing workflow productivity. As we proceed, we'll explore additional features and functionalities to enhance your SquidNet experience. Stay tuned as we delve deeper into the SquidNet main user interface, uncovering its full potential. Continuing from where we left off, let's delve into the features and options available within the MDI interface. Initially presented in a standard configuration, we'll explore how to optimize your viewing experience by adjusting the display settings to reveal more content within each sub-window. The current setup displays all screens within the MDI interface, offering a comprehensive view of available features. However, to enhance clarity and accessibility, users can switch to a tab view mode. This adjustment enlarges the interface of each sub-window, providing a more detailed perspective on the contained information. Upon selecting the tab view mode from the window screen, users will notice a significant difference in the configuration of the interface. While the screens remain unchanged, they are now organized to offer a broader insight into the fields and functionalities within each sub-window. This modification facilitates a deeper exploration of the available options and data. To toggle between the standard and tab view modes, users can simply click on the tab view window button, conveniently located in the desktop icon tray. This seamless transition allows for effortless navigation between different viewing configurations, enabling users to adapt the interface to their preferences with ease. Now, let's delve into one of the sub-windows and explore its functionality in detail. Specifically, let's begin by examining the cloud rendering interface. This window serves as a platform for executing cloud-based rendering tasks, facilitating the efficient generation of high-quality visuals. This interface provides an overview of all registered users within your SquidNet render farm environment. Whether you're operating SquidNet within a cloud rendering service configuration or a non-commercial render farm environment, this window serves as a centralized hub for studio and user management. Let's delve into the details. In a cloud rendering service sub-window, you'll encounter a comprehensive list of all studios registered within the system, regardless of whether they signed up through your website portal or by local desktop tools. Conversely, in a non-commercial render farm service setup, you'll typically find only one account listed, the default administration account, named Render Farm. However, within this interface, you can also configure operational parameters specific to each user. Upon clicking on a user account, you'll be presented with detailed client information. SquidNet distinguishes between studio accounts and user accounts. Studio accounts represent the companies overseeing the system's users. Examples include Disney and MGM. Within each studio account profile, you'll be able to define fundamental operating parameters for each client, including studio name used and application templates, which serve as user job submission forms accessible through various SquidNet user-side desktop interfaces. Furthermore, additional settings such as internal account settings, bridge account settings, LDAP server configuration, Microsoft Active Directory configuration, and cloud settings for the user and streamer interfaces are available for customization. Settings for archive image storage duration, user project retention times, FTP retention times, and parameters for connecting to the user's FTP server can also be configured here. Lastly, this interface allows for user account management. You can modify, tweak, or add users to a specific studio, granting you granular control over user access and permissions within your rendering environment. The job queue displays a listing of all active studio accounts on the farm along with details about the status of their jobs. Currently, there are approximately 38 to 40 different active studios within the local render farm. Examining the field parameters, we can observe various statistics such as the number of jobs queued, the number of jobs currently rendering, the number of nodes assigned, and the credits currently consumed. Credits are relevant only if the local configuration is set up as a commercial render farm service. Additionally, there are drop-down menus available for the status of downloaded frames, active slices for the user account, the number of frames rendering in the queue, and the percentage completion status, ranging from 0 to 100%. Other parameters include the project size upon upload, the output size before completion of the download, and several other column fields. To inspect a specific job, simply double-click on the name of the studio. For instance, let's examine one example. Upon double-clicking, we can see detailed information about the job's progress on the farm. For example, if we examine a job with only one task, we can view its progress, the number of frames or slices, its current status, the nodes involved, and whether it's completed or not, including the download step. Further exploration of these screens will be covered in subsequent videos. In the User Accounts tab within the Cloud Rendering sub-window, you'll find a comprehensive list of all the users currently logged into the system and those who have recently submitted tasks to the rendering farm. Each entry corresponds to a user account associated with the studio account. These accounts represent the active users on the farm, each with their unique set of parameters and details. By double-clicking on a specific account, you can access further information such as the account status, whether it's enabled or not, the username, password, and email associated with it. SquidNet offers a feature to automatically send job completion reports via email to users, enhancing communication and workflow efficiency. Additionally, administrators can assign leases to users, a feature which we'll delve into shortly. Furthermore, you can determine whether a particular account holds administrator privileges or not. The interface provides additional fields for each user, including their last login time, the platform from which they're submitting jobs, Windows, Linux, or macOS, the total number of jobs submitted, lifetime credits consumed, and various other pertinent details. This detailed breakdown allows for precise management and oversight of user activity within the rendering environment, facilitating effective resource allocation and workflow optimization. In the Leases tab, you'll discover a listing of all the active leases on the farm. Each lease essentially outlines the operating parameters for a specific studio, defining its characteristics within the farm's framework. The list on the screen displays individual lease profiles for different studio accounts. Within these lease profiles, administrators can specify the default operating parameters and constraints within the farm. For example, administrators can define which priority render queues are to be used, assign render pools, and other settings that allow specific behavior characteristics on the farm. Schedules can also be configured within this environment, enabling users to establish when rendering tasks should occur. Furthermore, administrators can define the overall system parameters utilized by each studio within the farm, tailoring the rendering environment to their specific needs. For those operating within a commercial render farm environment with SquidNet, there's the capability to allocate and deallocate render credits. These credits are then utilized and consumed by the studio and its individual users, allowing for efficient resource management. In the Cloud Rendering sub-window, let's explore the other tabs. First, the Activity tab lists network activities such as jobs, completions, errors, and user logins. Next, the Job Reports tab provides a listing of all previously rendered jobs on the farm. It accesses the SQL database, which tracks user activity, job completions, errors, and more. The data retention period is configurable. By default, records are kept for 6 months. For example, we can search for jobs completed within the last 3 days. After selecting the filter criteria and initiating the search, the database quickly returns a list of completed jobs. Each job is associated with a preview image and detailed statistics, including the rendering nodes used, whether it's a CPU or GPU job, and, if used in a commercial render farm environment, credits consumed. This feature is particularly useful for render farm administrators. Okay, let's move on to the Transfer tab within the Cloud Rendering sub-window. This window shows the current status of all uploading or downloading rendering content. Uploading content will typically be user project folders, user assets, and similar items. Downloaded content, on the other hand, will be completed render jobs, frames, and slices. We'll cover these types of content in more detail in a later video. For now, it's important to understand that this window is where you can monitor and track all upload and download activity to and from the render farm. This gives you a clear view of what's happening with your projects. The Job Queue sub-window within the SquidNet user interface shows a listing of all the active jobs on the render farm. You can see the status of each job, whether it's completed, currently rendering, or in another state. By clicking on a specific job, you can see a listing of all the job slices, their status, and whether they've been downloaded to your machine. You can also see the nodes that each slice rendered on. Right-clicking on a slice gives you options to re-render it, exclude it from rendering on a particular node, or view the application render log, which shows the real-time log from the current render. Down at the bottom of the job window, you'll see preview images of the current rendered slice. By default, SquidNet takes snapshots of every slice and presents them here so you can gauge the job's progress. Going back to the job listing, you have other menu options. You can change the job's priority, suspend or resume it, or reset it if needed. There's also a node exclusion option. SquidNet can automatically detect if a job has problems rendering on a specific node and exclude that node from the job's workflow. Another option lets you look at images, which basically gives you a basic preview image of each slice as it completes. You can also view each image in detail and look at the output folder to see how the output is formatted and where everything gets stored on the central storage server. In the CPU sub-window within the main interface, we list all CPU nodes on both the local and bridge networks. Currently, there are 73 physical render machines, all bare metal and active on the network. Most of the machines appear to be in use or active, with indications of running GPU jobs visible. Moving over to the GPU tab briefly, we observe that all running jobs are Redshift and Cinema 4D. Returning to the CPU tab, this window provides an overall status of all rendering nodes on the network. By right-clicking on a specific CPU node, further configuration options are available, including powering on or shutting down the machines, setting rendering priority, and managing availability. Additional options include logging in via RDP, viewing job history, and managing exceptions. Exceptions allow excluding a specific render node from a job's workload if it encounters rendering issues. Availability denotes the accessibility of the node. Users can manage the render farm by powering it up or down, restarting nodes, or shutting down specific or multiple nodes. Rebooting, shutting down, and various other options are also accessible. Remote desktop access is available, and users can schedule tasks to activate at specific times of the day. Alright, now I'm navigating to the GPU subwindow. Here, you'll find the status of all the GPU nodes within the network. Currently, we're displaying information for 162 active GPUs within our render farm setup. In this subwindow, you can easily monitor the status of both machines and GPUs. Most of the GPUs are currently busy with rendering tasks. You'll notice a variety of GPU models such as GTX 4090s, 2080s, 3090s, and more, listed in the tab. Each GPU entry provides details like the CPU and GPU usage percentage, along with Octane benchmarking scores. Additionally, you can see the current job ID being processed by the GPU. In our case, we're running C4D jobs that utilize the Redshift renderer. Furthermore, you'll find information about the number of virtual cores or CUDA cores available on each GPU, as well as the machine's wattage, current temperatures, fan speed, host RAM, video RAM, and the type of driver being utilized. In conclusion, SquidNet stands out as a premier solution for render farm management, offering a robust array of advanced features that streamline the rendering process with unparalleled efficiency and reliability. From its intuitive user interface to its powerful job scheduling capabilities, SquidNet empowers users to effortlessly manage complex rendering tasks with ease. Its seamless integration with leading 3D software and support for diverse platforms ensure compatibility and flexibility for studios of all sizes. With features like automated job distribution, comprehensive monitoring tools, and dynamic resource allocation, SquidNet sets the standard for optimizing rendering workflows, ultimately allowing creators to focus on their artistic vision without compromise. Whether tackling large-scale projects or tight deadlines, SquidNet proves to be an indispensable asset for any production pipeline, delivering unparalleled performance and productivity at every stage.